initial sizing of the separator. If you remember, we said for designing or choosing a suitable separator for any process, the first step was to know how much is the diameter and height required for the separator. And the layout is going to be selected according to GOR. Here, a horizontal separator is going to be chosen. And we want to use Aspen HYSYS to initially size this separator. So we need this information. The first thing that we need is the composition of the feed, and it's always available. We cannot do design of any unit without composition. We should know what is the composition. And this is all the data available. We know the inlet temperature and pressure, and the other data should be taken and should be calculated by Aspen HYSYS. So, when you enter this area, the first thing to add is know what are different components. And we are going to add all the components according to this table. We are going to have hydrogen, methane, till pentane. And we are going to add all of them. So hydrogen, methane, ethane, propane, N-butane, isobutane, N-pentane, and isopentane. You can see all the components here. Okay, as you can see, this is done. The next thing that should be done is to define a fluid package. And defining a fluid package means according to what equation of states do you want to calculate different parameters. Okay? And here, hydrocarbon molecules. So, as you can see, everything here is done. Now, we have done the properties step. We can enter the simulation area. Okay, let's see what we need. Here, the first thing which is required is the amount of different components in this stream. So, we will provide a stream and we will name it as inlet. We need to define the composition, and the composition is available here. Here you will find the composition that you have added to your simulation. So now you should just enter the mole fractions.
223. No, 0 to 23, the first one. 0.0.
1 0 is missed.
2064.
And you can see the summation is about 1. So, because this is the mole fraction. And when we put this one, it will automatically normalize to reach to completely 1. So, now we know the composition. We need to know some a specification for condition. We need to know how much is the temperature, pressure, and if we know the temperature and pressure, all the other compositions are going to be defined. From vapor or phase fraction, temperature and pressure, we need to know at least two ones. And the common thing that we know in most of the cases is amount of temperature and pressure. We have inserted the composition. By inserting the pressure and temperature, as you can see, it can easily calculate the amount of vapor and liquid. Do you remember the flash calculation? It was too hard. It was an iterative calculation. Here, by knowing the composition and by knowing the amount of temperature and pressure, it can easily calculate you how much is the amount of vapor and how much is the amount of liquid. So, when we know what is the condition, we just need another thing, which is actually to know how much is flow rate. And flow rate can be found in different ways. If we just enter one of these, molar flow, mass flow, or other things, easily it will calculate all the things. Suppose here the molar flow is considered as 40 ton per hour, okay? So if we just enter the mass flow, the molar flow, the volumetric flow, the enthalpy and entropy and the heat flow, everything is calculated. And as you can see, it's very easy to use these softwares to calculate all the physical properties we require. And here, when we have added the required condition, as you can see here, it shows, okay, it means that everything required for this stream is defined. Okay, now we are going to enter these a stream to a separator. Look at here. We need to have one inlet, one outlet for liquid, and one outlet for vapor. By easily defining a stream as the inlet, we can define a stream for vapor and a stream for liquid. It's done. It can easily show you how much would be the amount of flow in vapor phase and the amount of flow in liquid phase. And here we should just, if we want to consider any differential pressure or delta P, we can consider it here. The reaction, if is going to take place in separator, can be added. And rating always is about different types of sizing. So we said we want a horizontal. We should change it to horizontal, and we should choose ellipsoidal head, which is head of the separator. And you can see here that the configuration even can be changed if we want to use another configuration for the separator.